Hey everyone, and a special welcome to all you future librarians and information scientists out there. Are you ready to pull back the curtain and see how search really works? Good, because today we're diving into how natural language processing is completely changing the game for information retrieval. So let's just start with a question I think we've all felt. Why does searching a library catalog, or any database really, sometimes feel like a total lottery? You type in what you think is the perfect search term, you hit enter, and you get back nothing. Or even worse, you get a list of 100 things that have nothing to do with what you wanted. It's frustrating, right? Well, it all comes down to the beautiful mess that is human language and how computers need a ton of help to figure out what we actually mean.
So here's our game plan for this explainer. We're going to start with what I call the search engine's dilemma. Then we'll get into the real trouble with words. After that, we'll open up NLP's basic toolkit to see the tools of the trade. We'll see how those tools help us get from just words to actual meaning. And then at the very end, we'll do a quick knowledge check to make sure it all sticks.
All right, first up, the search engine's dilemma. At its core, the biggest challenge is all about translation. And I'm not talking about translating from, say, English to Spanish. I'm talking about translating a person's complex, nuanced idea into the super rigid, structured world that a computer database understands.
This brings us to the whole point of what we're doing. It's called Information Retrieval, or IR for short. This is the science and the art of getting the right stuff to the right person at the right time. When you type something in a search box, the system's job is to sift through this massive collection and find the things that truly match what you're looking for. This is the what of our problem.
And if IR is the what, then NLP is the how. Natural language processing is this incredible toolkit we have. It's where computer science, AI, and linguistics all hang out together, and they're all focused on one thing: teaching computers to understand language the way people do. This is what makes a search engine go from just okay to actually smart. Okay, so let's dig into the problem itself, the trouble with words. Why is our language so tough for a machine to figure out? Well, it really boils down to two main challenges that can totally trip up a basic search system. And this slide lays it out perfectly. These are the two big headaches. On one hand, you have linguistic variation. Think about it. Car, auto, automobile, they all mean the same thing. But if you search for car and the best document in the whole collection uses the word automobile, a dump search will completely miss it. That's what we call a failure of recall. You're not getting all the good stuff. Then, on the other side, you've got linguistic ambiguity. Someone searches for crane. Are they a bird watcher or are they in construction? Without context, the system has no idea and just throws everything at you. That's a failure of precision. You're getting way too much irrelevant junk. So how in the world does NLP start to fix these problems? It's not magic, believe it or not. It's just a really clever step-by-step process. So let's open up that toolkit and see what's actually inside. From a bird's eye view, this is what the process looks like. First, the system chews on every single document in the collection, using NLP to create a smart description of each one. That's indexing. Then it does the exact same thing to the query you just typed in. And here's the key. Step 3 isn't just matching keywords. It's matching the smart description of your query to the smart descriptions of the documents. Finally, it ranks all the matches based on how good that match is and shows you the best ones first. The very first, most fundamental step in all of this is something called tokenization. Before a computer can even begin to understand a sentence, it has to break it down into individual pieces, or tokens. It's like taking apart a Lego model to see all the individual bricks it's made of. This means separating words, of course, but also knowing what to do with punctuation and hyphens and all that stuff. All right, next up in the toolkit is stemming. This is a real quick and dirty way to deal with that linguistic variation problem we talked about. A stemming algorithm doesn't know any grammar. It just follows simple rules to chop off the ends of words. So words like automates, automatic, and automation all get chopped down to the same stem, automat. Now, automat isn't a real word, but that doesn't matter. All that matters is that they all get grouped together. It's fast and it's surprisingly effective. Now, if stemming is kind of like using a blunt axe, then lemmatization is like using a surgeon's scalpel. It is a much, much smarter process. Instead of just blindly chopping off endings, it actually uses a dictionary and analyzes the context of a word to find its true root form, which is called a lemma. And this right here really shows you the difference. Stemming, being rule-based, Might chop operates down to oper, which is fast but meaningless. Lemmatization, on the other hand, is smart enough to know that the root form of the word better is actually good. It understands context. Now, this process is a bit slower because it has to look things up, but the level of accuracy you get is absolutely critical for a high-precision search. So far, everything we've talked about has been about the structure of words. But, the real holy grail here is to understand meaning. And this next level of NLP, semantic analysis, this is where things get really, really powerful. Semantic analysis is all about solving that ambiguity problem. And it does this by using these massive databases of knowledge, called knowledge bases, that map out how concepts relate to each other. So if your search query has the words bank and money, the system can look at something like WordNet and figure out, oh, they probably mean a financial institution, not a riverbank. It's a total game changer.
Okay, that was a super fast tour of the NLP toolkit. So now, to help all this sink in, how about a quick knowledge check? Nothing too serious, just a few questions. You ready? All right, first question. What's the name of that process for breaking text down into its most basic parts, like individual words and symbols?
If you said tokenization, you got it. That's the one. Okay, question number 2. When you have words like car, auto, and automobile, all pointing to the same idea, what do we call that linguistic challenge?
Yep, that is linguistic variation. It's a huge reason why simple keyword searches often fail. Question 3 for you. Which process takes words like fishing or fished and gets them down to the root fish just by crudely chopping off the endings?
That would be stemming, our fast and efficient, if a little clumsy, friend. And last question. Which one of the two is more accurate because it actually uses a dictionary and understands the context of the word, stemming or lemmatization?
Lemmatization, of course. That ability to understand context makes all the difference. So the next time you use a library catalog and the search doesn't feel like a lottery, you'll know it's because of these amazing NLP tools working hard behind the scenes. I really hope this helped pull back the curtain a bit. If you found this useful, you know what to do. Go ahead and like, share, and subscribe for more deep dives into information science. Thanks for watching.